Okay, hi guys, hi everyone. Can you guys hear me? All right, so I will get started with the workshop first. Okay, so welcome to my workshop. So this workshop is aimed at beginners who are interested in Adreno and what it has to offer. Okay, so a little bit background about me. My name is Piete. You can call me Tom. I'm a year 2 computer science student who originally was from a polytechnic, and I studied biomedical engineering in Nanyang Poly. And I actually used Adreno in my final year project. And this is a snapshot of my final year project. So I actually used a Adreno Nano over here. And it was used in conjunction with a temperature sensor and a Bluetooth transmitter to get the temperature of the eye warmer, which was used to treat a meibomian gland dysfunction. And basically using this thing, right, we were able to regulate the temperature of the eye warmer as well as to display the temperature on the mobile application as well, if you can see on the right side. Yeah, so these are the content of the workshop that I'll be going through later. So a little bit of disclaimer. So the use of the external websites does not constitute an official partnership between our clubs and the organizations. We are just using it merely for educational purposes. So we also have a Slido. So if you have any questions, you can scan the QR code and ask whenever you like. I'll be keeping track of it. I'll give you guys some time to scan the QR code. Or you can take note of the Slido, so I'll type it in chat. All right, thanks. Okay, so if you want to follow along the Adreno, the workshop, you can go to the Tinkercad.com. So it's actually an Adreno simulator. So I can actually bring it up here. So if you go to this website, this is what it will bring. So you can click on join now, and then you can create a personal account. All right, I already have an account, so I will sign in. Yeah, so basically, if you want to follow along, please do sign up with the Tinkercad. And all right, so let's talk about what Adreno is. All right, so what Adreno is an open source hardware and a software company that designs and manufactures single board microcontroller and kits for digital devices. So they have different boards for different usages. Like the one in the middle is the Adreno Nano, which I previously used in my final year project. And it's also very compact and it doesn't require a lot of space. Also, there are Adreno Uno and Mega. These are used in projects where shields are required, which I'll get to later on. Or you also need, if you need higher processing power, you're also able to use these Adreno Uno and Megas. So Adreno in general are pretty expensive, but thanks to it being open sourced, there are a lot of various companies that exist just to create Adreno clones and sell them for cheaper. So here are some examples. And you can also buy an Adreno starter kit online for about $150. And actually most of them are out of stock due to the popularity of Adreno. So it's also pretty expensive. But then, like I said, it's open source. So there are a lot of external companies that create these kind of starter kits for way cheaper. So if you actually go to Shopee, you can actually buy these kind of starter kits for about $32. And they basically contain all the components that we'll be using later on in our workshop. So like LEDs, LED screen, Adreno Uno, yeah. So these are also Adrenal Shields. So if you're from computer science or computer engineering, right, you would have come across the NFC shield back in year 1. So they actually allows you to basically read an NFC tag, and yeah, you can do a lot of projects with it. And on the right side is is basically an Adreno joystick. It's a shield add-on. So you can use it to control like remote control cars using Adreno as well. So you even have a smoke detector and a Wi-Fi shield, and a Wi-Fi shield if you need, if your project needs it. So let's get on to the Adreno board layout. So you have a lot of inputs, like the digital input and the serial inputs. So you also have a serial in and out to communicate with other devices, such as a Bluetooth transmitter. You also have your power and your ground pins over here. And yeah, you will be connecting various components to the power pin later on as well using a breadboard. So there are two different type of inputs in the Adreno, digital and serial. Right. So what the digital pin would be is that it only has two values. Right. It's either high or low. Right. But then the analog input, you see pins are 0 to 5. They basically it can take on any number of values because Adreno has a built-in analog to digital converter, which will turn an analog voltage into a digital value. And we'll be making use of both the digital and analog pins later on. Right. So moving on, these we'll be using a breadboard later as well, simulator breadboard. So this is the inner workings of a breadboard, right? So if you can see here, it allows us to connect various things together. And the columns are connected vertically, while the rows are connected horizontally. So for example, if you will connect to J1, right? So here, the entire row, the first row, will be connected, interlinked there. It will be connected together. And then now, if you were to actually buy an Adreno board itself and you want to connect it to your computer, there are some things that you need to take note of. Right. Hope you guys can see the Adreno ID. So under tools, you will need to choose the correct Adreno board here as well. And then for the ports, you need to connect to the correct USB port so that your computer can basically communicate to the Adreno. And now that I have the IDE open, I want to talk to you about the two different zones here. So we have the setup zone here. So these are basically, you put your code here and it will only run once, right? So, and then you also have your loop function here. This one is self-explanatory. You basically put your code here and it will repeatedly run over and over again. All right, so let's head over to Tinkercad. All right, so here, if you want to follow this, you need to click on circuits, right, on the left side, and then you need to create a new circuit. All right, I'll give you guys some time if you guys want to follow. Okay, I hope everyone has the Tinkercad open as well. So let's get started. So here we can click the components and you can go to Adreno and you can click a breadboard and it will appear. So here, this is the breadboard I was talking about. So here, the ground is connected to this line. So the entire line is connected. It's basically interlinked. And the 5 volt is connected to the plus sign. So this one is also interlinked. So like any other coding tutorials, let's start with hello world. So, you can go to code. So these blocks, you can basically ignore them. You can just go to text over here. Right. Yeah. Basically continue. Right. So to actually, Adreno also has a serial monitor. Like any other IDE, you can write to the serial monitor as well. So if you want to write to the serial monitor, you need to initialize it with serial. So this will basically allow you to initialize the serial monitor. And what the 9600 means is basically the baud rate. So it means that the serial baud can transfer about 9600 bits per second. And now you can simply print hello world by using serial.print. All right, and then you can run your simulation. All right, and then you can, because it's in a loop, right? So it will continuously be printing a hello world. So you can also use print line if you want to have, if you want to go to the next line every time you print something. So if you don't want it to be looped, well, you can just copy and paste it to here. And like it suggests, it will only run once, right? It will just be hello world. So now let's actually start with blinking and LED. So this is the most basic part of Adreno workshop, right? So once you click and drag, you have this pop-up menu as well, and you can change to the colors to basically whatever that you want. And you can also rename it. So yeah, you can rename it LED1, right? And for those who don't know, the LED, right, it basically has a positive and a negative. So anode is the positive and cathode is the negative. And usually in a physical, like if you have a physical LED, right, it'll be very easy to identify the anode and the cathode because the anode will always be, the pin of the anode will always be longer than the cathode actually. And here, basically the lengths are the same, but there's another way of telling which one is cathode as well. You can look at here. So one side, the anode side will be rounded and the cathode side will be basically flat. All right, so you can connect it here. And also you will need a resistor because if you don't put a resistor, the amount of current that will flow through the LED will basically fry the LED. Yeah, so you'll basically, the moment you connect without a resistor, the LED can explode sometimes. So yeah, so you will connect it to the positive side of the LED, right? And then you connect it to the plus. And you can also change the color of the wire using your number keys. All right, so 1 will be black, 2 will be red, so on. And I'll connect it to the plus side, and this one will be to the negative side. All right, so now that that's done, we can start writing code to blink the LED. All right, so here, at first we will need to declare where the LED is connected to in the to the Adreno. So sorry, I made a mistake. So here, you will basically connect it to a 13. So you can connect it to any digital pin that you want, but then you have to declare it afterwards to which digital pin that you are connecting it to. So for example, so you see here 13, I've connected to 13. So I need to write constant. So I'll be declaring, yeah, so basically I declared that I'm connecting pin 13 to the LED. And this constant means that the LED pin won't be changing throughout the entire project, right? So you want to set it up outside the setup and the loop functions because you want it to be a global variable. So what a global variable means that you'll be able to access the LED pin from both the setup and the loop functions, right? So now that you already declared the LED pin, you will need to declare the pin as an output because you're going to be outputting a signal towards the LED pin, right? So to do that, just need pin mode. So this one will basically declare that the LED pin 13 will be used as an output. So now that that's done, if you want to write it, if you want to turn on the LED, you just need to put so because we're connected to a digital pin, we'll be using a digital write. So basically we'll be turning it on. All right. So if you start simulation. So yeah, it'll be turned on. And so we can now stop the simulation. And then we can also put a delay in the loop as well. So what it would do, it will let the LED stay on for 1 second, all right? And then we can also turn on and off the LED. So we'll be using, and then you wanna delay it for a second as well. So what this will be doing is it will be turning on, it will wait a second, then it will turn off, then it will wait a second, and it will continue looping throughout the entire thing. So here, so as you can see here, the LED is turning on and off. All right. So we can now modify the code to make it so that the delay time will increase and decrease as the time goes on. So at first, the LED will be blinking very fast, and then as time goes on, it will be blinking very slow, and then so on and so forth. It will just keep on looping itself. So to do that, we will need a function. All right. So first, let's declare delay time. So here, now that I already declared it, I can use it instead of 1000. So I can keep changing the delay time as and when I want it. And then we also need a direction. So what the direction would do is to whether increase or decrease the delay time as meant by our code. So first of all, now that that's done, all right, we will need to make a function. All right, so let's say we want to check direction, and we will be putting in delay time and a direction. So here, it would actually be returning, the function would actually be returning an integer. So we need to declare it in a function. So it will be integer. So here you go. So integer. So the bad thing about this this Adreno simulator is that it won't close the curly brackets for you. So you have to do it yourself, and it's a bit annoying. So yeah, other than that, everything's good. So we will want to make it so that every time the delay time hits 1000, all right, we will want it to change direction. And if the delay time from 1000, it goes all the way back to 0, we also want to change it back in incrementing. So to do that, it will be or, so it will be delay time or. Yeah, so what this basically does is if the delay time is 1000 or the delay time is 0, it would basically go into the if statement and to run the code that are written below. So you can also use AND. So these are logical operators, right? So for people that don't know, logical operators, you have AND, OR, XOR, all these. So for AND, you basically need both of these things to be true to run the code. But if it's OR, you just need one of these things, one of these things, right, for it to run the code. So for here, we would, if it hits 1000 or 0, we want to change the direction of the. Yeah, we want to change the direction. So I'll be writing this, which is basically, this, but I want to shorten it. So I just put it like this. And you can rewrite it in a way so that you don't need to repeat direction again and again. Yeah. So then we also want to know if the delay time is increasing or decreasing. So if it's negative, right, which means that it is decreasing, we will want to write to serial that it is going down. So over here, you have that. Now we need to close it. Else, right? So this is if the direction is not negative, so it's going up.
Are you?
Yeah. So then in the end, we want to return direction because we want to know in this, when we call the function, we want to know whether the direction will be going up or going down. So here, then we return in direction. Then for that, yeah, so we already declared direction here. So we want to know the direction, whether it'll be plus or negative, right? So we'll be able to check the direction through here. And then to increment or decrement using direction, what we just need to do is delay time equal to plus. So if it's in the negative direction, which means that it will be going down, it will basically minus off 100 from the delay time every time it runs. Right. So then if it's in the positive direction, it will be just positive, right? So it'll be adding 1 millisecond to the delay time every time. Right. So you can also print out delay time if you want to keep track of what the delay time is. So if everything works, this thing should be running as intended. So all right, so yeah, basically I missed out a curly bracket. So this is why I said it doesn't auto-complete it for you, so it's quite annoying. All right, so you can start simulation. So if you can open a serial monitor here as well. So you see, if you see here, it'll be slowly incrementing until it hits 1,000, right? And then it will basically go into this function and it will say that it's going down. And if you see here, it's going down and it causes the delay time, the LED to blink faster and slower, as and when you intend it to be. Okay, so I hope everyone is able to follow. Right? Yeah. The anode is also a bit crooked, so it's also that's another way to tell whether it's anode or cathode as well. So I hope everyone is able to follow along. And if anybody has any questions, you can send it over to the Slido as well. I'll be looking at it. Is everyone able to follow along? All right. I hope everyone is able to follow along. So we will move on to the next section. So next, I would like to show you how we can incorporate arrays to control the number, to control basically different LEDs. You can blink different LEDs. Yeah, you can basically code it in a way so that it will blink in a row. So for that, we will need to add more LEDs to it, right? So we will want to add more LED and resistors because we'll be putting the pins in an array, and we'll be looping through the array to basically output to light up the LED back and forth. So let's say we can put around 4 LEDs. So yeah, it's basically just the same thing. So this one, the cathode will go to ground. And then for this, you will want to connect it to a digital pin. So here. Okay, so these are all connected to digital pin 13, 12, 11, and 10. So in the code, we can declare an array. All right. So how we're going to declare the array is simply integer an array. And we want to put in the digital pins that we've connected the LEDs to in the array itself. So it'll be 12, 13, 12, 11, 10. Right? So basically this it'll be done. For now, let's get rid of this because we won't be using the direction anymore. So we will need to, for now, right, you see the LED pin just now previously, you only declared 13 as the output. But now we have an array with 4 different LEDs that we will need to declare as an output. So to do that, you just need to make a simple for loop. I equals to 0, I less than 5. So for people that don't know what an array is, basically the index of the arrays would start from 0. So it'll be 0, 1, 2, 3. So yeah, basically if you want to loop from 0 to 3, this will be the terminating condition. So if it's anything more or equal to 4, the loop will stop. All right, so you just put I++. So it will increment every time it loops through the code that we're going to put. So for this, we need to make a curly bracket again, and basically
shit posting
will be
what can't you gotta have thicker skin.
yeah. So what this would do, right? So it'll basically loop through the array. So it'll take 13 and it'll make it an output. It'll take 12 and it'll make it an output. 11 make an output, and so forth. So here we already declared the entire 4 LEDs as output here. So we will need to, so we'll be able to start turning on the LEDs in the loop function.
Zoom.
All right.
Maybe you should reduce the zoom stuff.
Sorry, Tan, can you, is it possible if you can mute yourself?
Oh, sorry.
Yeah, no worries. Yeah, so if you want to loop through the LEDs, right, we basically have to do the same array as well. So initial I equals to 0, I less than 4. So here, we basically just copy and paste the code because we're lazy. And yeah. So here, previously it was LED pin that we were outputting to, right? But now it will be an array. So we'll be outputting to the indexes in the array. So it'll be, so here, it'll basically, when I is equal to 0, it will cause the 13, which is here. It will cause this to turn on, and then it will turn it off. And then afterwards, it will move on to the next index, which will be 12. So it will be asking this to turn on and off, and then so on and so forth. So here you can just change the color so it's more colorful. So, okay, so we've already turned it on, and we can also make another array, another for loop, so that it will turn itself off. So I equals to 3. Yeah. So this would, we can just copy and paste the code from here to here as well. So what it would do is once it goes to the last LED, right, it will also go back to where it came from. So all right, so yeah, we need to change this as well. Because here we are also telling which LED in the array we want to turn off. All right, so if you see this for loop, we start from 3, we'll end up at 0. So it will be starting from 10, then it will go all the way back to 13. So it will be like, it'll be flowing back and forth. So you can. All right, I forgot to put it. Yeah, so here, okay, I think we can make the time faster. I mean, we can make the delay time longer so you can see the individual LEDs turning on and off. All right. Yeah, so once it reaches here, oh, sorry. So I made a mistake here. So it's supposed to be minus minus, right? Because we want to decrement from 3 to 2 to 1 to 0. So instead of plus plus, it should be, so when you stop stimulation, we need to minus minus, and it should go back and forth. Yeah, I made a mistake there. All right, so you can make it, you can also, use the direction as well to change the amount of delay time that you want. So you just need to basically just reuse this function and insert it here, but I won't be doing it here. So next up, let's move on. We can, for now, for all this while, we've been using the digital pins, right? So if you remember what I said, it can only make high or low. So the two outputs are only high and low. So now let's make use of the analog pins, right? So for that, let's use a potentiometer. So for those who don't know what a potentiometer is, let me just show it to you. So it basically has 3 pins. All right, so power, ground, and middle is the signal. So the variable resistor will basically allow you to change the resistance when you twist it here and there. So you'll be using the amount of resistance, amount of voltage drop across the analog pin to basically turn it into a digital signal. So let's go back here. So here, basically, it doesn't matter which terminal is positive or negative. It doesn't matter. All right. So here we'll be using ground. So put it here. And so for the wiper, this is where your signal is going to come out from. So we want to connect it to, let's say, analog 0. All right. So this A0 over here. And we can get rid of the LEDs here as well. So you can just click delete. Yeah, so let's just make it cleaner. All right, so So what's the difference between a Raspberry Pi and an Adreno as a microcontroller? So Raspberry Pi is also another microcontroller, right? So, but it's also depending on the amount of processing power that you want to use, because you can use a Raspberry Pi as an operating system as well. I believe it's a built-in operating system, but Adreno is just, it's basically like it's just a microcontroller. It's not able to run any any OS onto the board itself, because the controller here, you see the controller here, it's a ATmega328, which is a very, it's basically pretty, very low processing power. So you can't run any software on it if you want to. All right, so let's move on to the potentiometer. All right. So start code. All right, I'm just going to delete all of this because we're not going to be using it anymore. All right, so first of all, let's map. Let's declare what the two inputs are. Right? So it'll be integer. Now, let's just call it a variable resistor. Right? 0. So here is 0 because we're connecting it to the analog 0. So for here, we will need to declare the LED pin as an output again. So it'll be and here we want to declare the potentiometer as an input because we're going to be getting signals from it. So here will be an input. So for here, right, let's create an integer called value. And since we're going to be reading from it, and it is an analog, we're going to be using this called analog read. And we're going to be basically using this equal. So what this would do, right? So when we change the resistor value, it will be translated into a digital signal, and we'll be able to get the value of the changes in the Adreno itself. So here you can so if you run the simulation, all right. So here it's outputting 0 because we haven't moved it yet. So you see, once I started to move the potentiometer, the value in the serial monitor will change, correct? So it goes from 0 to 1024, 1023, sorry. Yeah, so we're making use of this, right, to control the LED brightness using the digital output. So to do that, we will need to use this thing called map. Right? So we need this. So here, right, we will also need to connect the LED pin to actually, we need to connect the LED pin to this this input with a squiggly line on top of it. So what this is a pulse width modulator. So how it works, right? It's basically like this. So when we write analog write 255, it will be 100% duty cycle. Okay, and when it is 0, it will be a 0% duty cycle. So because how this works, right? So the scale of the pulse width modulation is from 0 to 255. So it will alter the amount of on time the LED is getting. So the amount of voltage that the LED is basically getting. So let's say at 100% duty cycle, you'll be getting the full 5 volts. And at 75%, you basically get 75% times 5 volt. That's the amount of voltage the LED is getting, because it goes on and off. So the analog, the amount of value you put in the analog write will basically determine the amount of voltage that the LED is getting, which will cause it to be brighter or dimmer depending on the value that you put in. So here in the code, what I basically did was to map 0 to the lowest limit of the potentiometer to the lowest limit of the LED, right? And then the highest limit of the potentiometer to the highest limit of the LED. And we also need to change the pin output of it. So yeah, see some of the pins here have the squiggly lines. That means you are able to produce a PWM here. So, all right, now that that's done, we will need to use analog write. As I've mentioned here, it will be analog write. So yeah, this one is just you can see here, this we'll be writing to the LED pin with this value over here. So some of you might be wondering why the value is from 0 to 255. It's because the analog to digital converter inside the Adreno is 10 bits. So 2 to the power of 10, you'll get 255, if I'm not wrong. So that's where the value actually comes from. Oh yeah, sorry. Yeah, sorry. I was talking about this potentiometer actually. Yeah, sorry, I remember the wrong thing. Yeah, the reason why it's just 0 to 1024 is because you're using the analog here. So ADC is 10 bits, so it'll be 0 to 1024. Yeah, sorry about that. So once you write it here, let me just make sure everything is correct. All right, so when the value is, yeah, it's actually 1023, it doesn't really matter. So when the value is 1023 at the maximum, it's actually, you see the LED is at the brightest. And then once we turn it on, turn it back to 0. Oh yeah, sorry. You can also, if you want to keep track of the value, you can also write. So just, and we'll be able to monitor the value here. So at 0, it'll be basically off. And then here, if you're 127, it will be at half brightness. And if it's at 254, it will be at the brightest here, right? So yeah, and then if you want the LED to be brighter, you can also change the value of the resistor here. So if you see right now the resistance is 1 kilo ohm. If you want it to be, let's say, just 560. So basically it will mean that there'll be more current flowing to the LED and it'll be brighter. Right, so yeah, you can just see the difference. Okay, so now that we have written to the serial, right? Let's move on to another section. We have actually written the serial, right? Now we want to write to the serial. So what we will need is this. Yeah, so basically we wouldn't need this anymore. Right, so let's delete this part of the code. So I would need to do this. I need to write out this code that says while serial dot is more than 0. So just bear with me while I write the code, and I'll explain it to you later on. All right, so it'll be here. So basically, for this, all right, this serial dot available, it's actually to get the store bytes from the serial port that are available for reading. All right, so only when there is something in the serial that we have written to, that it will read the, it will read this thing, right? So, and then the serial dot parse int. So basically, what parse in means that from the serial monitor, right? I think I can just show it to you. So it will only take in. Sorry, I didn't declare. It's a little laggy here. Yeah, so what I forgot was basically to declare the num here. So it didn't know what num meant. So if you do this, right? So right now it's 0. But then if we were to input a number, you see how the LED has turned on, and now the num is basically just 255, because without this, all right, without this thing, let's say we were to get rid of it, what we will get is just every time we write a value to it, it will read it, but then it will also reset itself, because how serial works is that if it hasn't received an input in, like, let's say a certain amount of time, it will always be 0. So that's why we need this serial dot available to basically say that to read only when we have typed something in to the serial monitor. All right. So now what parse in does is that whatever you type in, like let's say you've typed in a string as well, right, along with a number, an integer. What parse in does is it will only take the integer in the serial monitor, and it will basically discard the strings. So if you put it in, all right. Yeah, but I mean, it's not working here for some reason, but basically, when you use parse int, it will only take in the integers and it will ignore basically everything else. So yeah, here you can type in any other numbers here, and it will basically light up amount. Like it was basically previously using the potentiometer, except now you're typing a value in, and it will change the value, the brightness of the LED accordingly. All right. So now let's move on. All right, let's move on to something. And now we can actually create a an intruder alarm, right? Because these things are, you know, turning on and off a LED, you might not find it interesting. So we can create a intruder alarm. So what we would need, all right, is first a PIR sensor. So this one is basically a motion detector that we'll be using. Right, then we also need a piezo. Right, so this one will basically be the one producing the sound whenever someone steps in front of the motion detector. Right. Then we also want a button where we can push to disable the alarm when it starts ringing. So like without you pushing the button, the alarm will continuously ring. So, right, we don't need these things anymore, so we can just get rid of it. Yeah, so for the buzzer, basically, it only has 2 pins, right? So this is positive and this is negative. So we'll be connecting the negative to ground as usual, and we can change the color as well. And then we can connect the positive to a pin, to a digital pin. You can change the color as well, so we won't be confused. And let's put it to 10 to make it nicer. All right, and then this will be the motion detector, like I said. So here, this is power, just because we're not writing anything or reading anything from power, we can just connect it as usual. So this one will be to plus and ground will be to minus. And then the signal is the one that will be receiving the inputs from. So we will need to connect it to, let's say, any digital pin that you want. So let's say we connect it to 7. All right, and then the button. So for the button, the internals of the button actually, give me a moment. Yeah, so the internals of the button actually looks like this, right? So it's basically an open circuit here. And then once you press a button, it will be closed. So we just need to press a button. And I also want to introduce to you one new concept. It's called a input, a resistor, a pull-up resistor, right? So what it means that, imagine this is our Adreno pin. This is our input pin, our input digital pin. And we will be able to see whether the button is pressed or not using a pull-up resistor. So if you see here, without the button being pressed, it's basically an open circuit and there's no current running across the resistor. So there is no voltage drop across a resistor. So if you measure the voltage at the input pin, you will basically be measuring the voltage at the VCC. And if you remember, digital pin, it only has 2 outputs, high or low. So if it's if you detect voltage, it will be high, and if you don't detect any voltage, it will be low. So when you press the button, the button will be the circuit will be completed, right? So now there will be voltage drop across the resistor. There will be voltage drop across the resistor, and it will flow to the ground. So when you measure when the button is closed, you'll basically be connected to the ground, and you'll be measuring 0 volts. So you'll be able to get an input of 0 when the button is pressed, and when it's not pressed, you'll be able to get an output of 1. All right. So this is what we'll be doing. So basically, it doesn't matter which side of the terminals we use. We just need to connect one of them to ground. Then we will also need a resistor. All right, we will need a resistor and connect it to the plus, because if you see this is a resistor connected to the plus, and then in between that, we will be connecting a wire from the plus to a LED pin, to a digital pin. So let's say we want to connect it to pin 11. So now that we've gotten the hardware down, we can now move on to the software as well. So here, first we'll need to redeclare the pins that we have connected to. So for the sensor, for the PIR sensor, we've connected it to 7, so we will declare it 7. And then for the buzzer, right, we will call it a buzzer. We connected it to 10. And then for the button, we've connected it to 11. Right? Okay, so now we need to declare what the mode of the pins are. So for here, this is actually an input, right? So for the PR sensor, we are getting an input whenever someone moves in front of it. And also because we're connected to the digital pin, right? The output will be either 0 or 1. So yeah, this is something to take note of as well. So we're connecting it to 7. And then the buzzer is we're going to be outputting something to it. So it's going to be output, right? Oh, sorry, why did I type 7? Right. And for this, for the button as well, it is a input. So we're going to declare it as an input. So that's all done, right? So now we're going to move on to the loop part of the section. So let's create a integer value called sensor, and we'll be storing this the value that we read from the digital pin 7. So previously we wrote analog read, correct? So now that it's digital, it's going to be digital read, right? So this is it. And then we also want to get the value. We declare another variable. And then we want to know when the button is pressed. So we're storing the value into here. So digital read. And then, all right, so let me just show you what the output will look like whenever something occurs, right? So yeah. Yeah, okay, so it's a little fast. All right, so if you can see, the sensor value is 0 because there is nothing in front of it, right? And the button value is 1. Oops. Yeah. So sensor value is 0, button value is 1. So when we press it, the button value would also go to 0 because we've completed the circuit, and basically the digital pin will be reading from the ground. So it's not getting any voltage, so it will be low, which will be counted as 0. And then you can simulate someone going in front of the motion detector by just clicking on it, and then you'll be able to see. So this will be your object, all right? So once you go in front of it, this thing will light up, and you see now that the sensor value is 1 as well because something is in front of it. So this is where we're getting the signal from. So once the object moves out of the range, yeah, it will just go back to 0. So you see here, it takes a while to revert back to its original position. So you see now the button, the sensor value is 0. Right. So now you can just get rid of all this. So now we want to incorporate the buzzer as well. So if the sensor, we sense something in front of the sensor, it will give an output of 1. We will want a buzzer to run as well. So this is if it's equal to 1, right? And then this is where the button comes in. So let me just type out the code first, and then I'll explain it to you later. All right, so what I have written here is, so when the button is 0, which means that we've pressed it, we want to stop the buzzer noise. All right, so this is what it does, no tone. So this will basically stop the buzzer. And then here, if it's not pressed, right, we will want it to run. So this is what the code is for, tone. All right, so this is how you would make the buzzer run. So here at tone, the 1000 is basically the frequency of the frequency at which the buzzer is going to ring. So if you start here, and when you do it on your own, the noise is quite loud, so just be careful. Yeah, it's loud for me, so I'm gonna no. So you see, even when I move it out of the way, it's still ringing until I press the button. So let me just bring it closer. All right, so it's ringing. All right, someone moves away and it's still ringing until I press the button. So without the button being pressed, the buzzer is continuously gonna ring until you tell it to stop. And then you can also change the pitch. So let's say you want to go very low pitch, right? You can stop the simulation. You want to go very low pitch, and then you can basically change the tone of the buzzer, whatever you like it to be. So here the noise is going to be very low, and as long as the person is in front, no matter what I do with the button, yeah, so it's just going to stop when I press the button. And so basically, this line of code will basically help you to change the frequency the buzzer is outputting. So with this, right, you can actually create a lot of things. So you can create even like a musical arrangement using different frequencies, but I'm not going to get into that here. All right. So yeah, this is basically an intruder alarm that you can make at home if you want to, because if you buy the Adreno starter kit, I believe all these things will be included in the starter kit as well. So if you want to, do it physically, you can do so. All right, then let's move on to the last section of the workshop. So we're going to be displaying something on a LED screen. All right, so for that. So if you see here, this is basically the schematics of the LED screen. Let me see if I can send it. All right, I'm not able to send a picture, but I will send the link, right? So it's just you can go to here. You can follow along because there's a lot of connections that we need to do. So even if you want to do it physically as well, you will have to connect all the pins as shown in the schematics as well. So for that, let's delete everything because we won't be needing any of them here. So here, if you scroll down, I believe it will be under all. Right, if you scroll down, you also have quite a lot of different sensors and inputs that you can choose from. So this was the temperature sensor that I actually used in my final year project to basically get the temperature of the eye warmer, but we're not going to be using that here today. Yeah, so you can basically this simulator has a lot of different items that you want. So you can take the LED 16:2. So if you look here, if you're looking at the schematics as well, right? See. So if you look at the schematics, yeah, you can see where the pins would be lining up to. So you see LED pin. So this is the minus. So here, this is the minus. And then it corresponds basically to whatever the schematics is. So plus, and here we won't be using, we won't be connecting anything from DB0 to DB3. Just be basically using from 4 to 7. Yeah, so here, you can follow along using the schematics as well. So this is basically just mix and match. It doesn't have to be, yes, it doesn't require any skill. It's just basically mixing and matching. Also for this, you will need a potentiometer as well. This one is basically, it will control the backlight of the LED screen. And we also need a resistor for the LEDs inside for this LED here. All right, so you just, at this point, you will need to basically follow the schematics. All right, but if you're too lazy, right, they're also pre-built. They also pre-built like lessons here in a sense. So you have a tone keyboard. You have basically a lot of different projects that you can choose from here. So if you're too lazy to basically, build the LED, you can just delete everything. Right. You can just bring in a pre-built one for you. And before I do that, let me just delete everything here so that it doesn't get confusing. Yeah, so if we were to connect it ourselves, this is how it would have looked like. So you see this pin, the LED is connected using a resistor as shown here. C plus is connected to a resistor and it's connected to a 5-volt. And then it's the potentiometer is connected. If you follow the wire is connected to V0. And this is what we observe here as well. It's connected to V0. And the rest of the board is basically just copying from here and there. And if you go to the code, this is basically saying which pin is connected to which pin on the Adreno, and we don't need to use any of it. So to display on the LED, right, we will need to use a library called Liquid Crystal. You can get it from here. If you go to libraries, you also have different libraries that are already inbuilt for you. So you have like, servo motors. So this is the one that we'll be using, which is Liquid Crystal. And you also have keypads and everything. So if you want to do any other projects that requires library in this Tinkercad, you can get it from here. Right. So this one basically imports the library here. And this is to declare the pins that we've connected to, right? And so this is the actual setup. So this one will basically, it's like the using pin mode output. So this will basically initialize that LCD. And if you see here, you can use LCD print and hello world. So this one, yeah, you can run the simulator. And basically, this will be print out hello world. You can also explore different things that the LCD can do. So if you go to here, if you click on this link, there's a link to documentation, right? So here you have all the, basically you have everything that the LCD screen is able to do. So like if you wanted to scroll, you can do that. Or if you wanted to, if you wanted to blink, all these you can find a lot of documentations online that because Adreno is open source, so it's a lot of people contributing to the software as well. So they are basically pre-written libraries that you can just import, and you can read a bit of documentation, and then you can start doing whatever the project is you want to do. So here, this is basically just telling you the hardware required, the pins here and there, the schematics again, and then here. Yeah, so there's also like different functions. So like scroll display left, right? So if you were to just copy here. I think I need to refresh. Yeah, so if you see here, because we did this called scroll left, it will be scrolling to the left. And there's also a scroll right if you want to scroll it back. Yeah, so here, basically display right and display left. So yeah, I think this is the end of my workshop actually, because anything further than this, it will require more knowledge about circuits and how you're supposed to connect circuits. You need like knowledge on electrical engineering basically. So I think this is a good beginner workshop where I teach you the skills you need to basically venture into the Adreno world. And so I have some more questions from the Slido here. So here. So analog write converts an analog number to a digital output, which is supplied to the LED. Yeah, so from the, so using the potentiometer, right? It's here. So that this is just me trying out previously. Yeah, so whenever you turn this thing, it would be connected to a it'll be connected to an analog pin, right? So it'll convert the analog values into a digital value using the analog to digital converter, which is already included in the Adreno. And then it will take the digital value and it will feed it to the LED so that basically it will simulate the amount of amount of cycles that the amount of voltage cycles that the LED is getting, which will in turn see how bright or how like dim the LED is getting. Right? So there's one more question, which is, what's the difference between output with a squiggly line and an output without a squiggly line? So if you were to see here, the squiggly line means that it basically supports the PWM, the pulse width modulator, right? Which is basically this. It supports this this thing. So here you're able to basically control the amount of voltage that the output is getting. So if you were to connect it to, let's say if you were to connect it to 13, right, without the thing, right, without the squiggly line, nothing will happen because the pin itself is not able to vary the amount of pulse generated to the voltage, right? So if you want to control using a PWM module, you would basically need to use output with a squiggly line. And I have one more question here. Is it a must to use a liquid crystal library when handling an LCD? Yes, I believe so, because it has various functions that are included in the library itself. Right, so let me go back to the previous one. Yeah, so you see here, without the liquid crystal library, right, you won't be able to initialize the LCD here. So because we included the liquid crystal library here, we're able to initialize the pins that we have connected to. And then because we initialized, we're able to use these lines of codes in our program. Without it, LCD, like the software wouldn't know what an LCD dot means, because it doesn't have the library to look up what these things mean. So that's why you need to basically include a library for the software to look up what these lines of codes mean. How powerful is Adreno in terms of the processing power? So it will vary based on the Adreno, which Adreno board you buy. So I think it's, so if you can see here, right? Yeah, so these are the various usage of these things. And let's see, because I myself is not sure about the processing power of the Adrenos itself, because I've never exceeded the amount of processing power that is yeah, I've never exceeded the processing power basically. So I think if you want to find out more, you can Google it. I'm not finding the answer here. Yeah, so I'll stick around for a while, but this is basically the end of the workshop. I have nothing further that I want to share as well. Yeah, so if you look at the Telegram chat, we have sent a different links to our social media basically. So if you want to join our mailing list or Telegram, you can click on the links. There's also the Women in Tech LinkedIn and Telegram that you can also subscribe to, because they also do workshops every Tuesday, if I'm not wrong. So you can basically attend your workshops as well, regardless of your gender, even though it's called Women in Tech. Yeah. Yeah, so I'll just stick around and so I believe if you're already attending the workshops, right, it's already you already considered a club member. It's whether you want to be an exco in the club. So we have different roles in the club as well, like publicity, tech directors, various roles in the club. And if you want to sign up for it, I believe we have a recruitment drive. But just as a club member, you already consider a club member when you attend these workshops. Yeah, I think our OSS president is in a discussion whether for the people that attend these workshops, right, whether we will be able to reward CCA points to the people that attend the workshop, but it's still in the works. So we will let you all know when we find out as well. Yeah, so do follow us on Telegram because any further workshops that we'll be presenting will be basically it will be shown on Telegram first. Anyway, thanks to everyone for attending the workshop as well. I hope you've taken something away from the workshop, and I hope you can continue the projects on your own as well. Right, so yeah, we also have a upcoming workshop next Friday, the 3rd of September. I believe the topic is going to be predicting cryptocurrency prices using neural network. So keep a lookout for that. And yeah, here are the QR codes. If you don't want to type in, the recording will be uploaded, I believe, to YouTube. So you can go to YouTube and search Open Source Society NTU, and you'll be able to find the recording as well. And I'll stick around for about 5 more minutes and then I will end the session.